oscilloscopes all follow a similar data collection process. After a triggered event, the scope will capture and display the input signal. After the data display, the scope will perform some housekeeping duties and ignore any triggering events. This is known as dead time. During this period, the scope may miss some abnormal but very key signals. This missed data extends the debugging time and reduces your debugging efficiency. Many Regal oscilloscopes feature ultravision technology. Compared with traditional oscilloscopes, instruments with ultravision have high waveform capture rates, which greatly reduce dead time and improve the likelihood of capturing random events and abnormal signals. On our demo board, there is a 1 MHz square waveform, but there is also a narrow pulse every 100,000 cycles. Let's capture and trigger this narrow pulse using a high capture rate oscilloscope. Since the rate of this pulse is very small, it will only appear on the display for a short time, making it difficult to observe with the human eye. First, we can set the persistence level to keep it on the screen. Let's set it for 2 seconds. Now we can see the pulse on the screen more clearly. You can also set the persistence time to infinite to keep the captured pulse on the screen infinite. Now we can estimate the pulse width to be about 5 nanoseconds. In order to observe and measure this narrow pulse, we need to use the pulse trigger. We'll choose pulse width in the trigger mode, set the source to current channel 1, pulse width condition is pulse width less than. Let's set the pulse width less than 10 nanoseconds, set the trigger mode as normal, and adjust the trigger level until we can see the pulse clearly. And now we can also verify that that pulse width is 5 nanoseconds. The capture rate differs with different scope settings, mainly influenced by the horizontal scale, sampling rate, and other functions that may be active, such as interpolation, math function, measurement and analysis, and some others. To achieve the highest capture rate, we need to understand the capabilities of the oscilloscope and make adjustments to the data depth, horizontal scale, and by enabling or disabling any measurement capabilities that we have. Here is a convenient way to check the capture rate. Set aux output as trigger output, and then measure the signal frequency output from the rear panel. This concludes the introduction to high capture rate oscilloscopes. The key points are: use reasonable settings to get the highest capture rate, use the persistence model to observe any abnormal signals that may happen very quickly or at short intervals, and set the right trigger condition to stabilize the abnormal signal. Thank you.